Hello again, everybody. Do not adjust your monitors. I know that I have the old derivative rule written on the whiteboard, but we're actually going to use this derivative rule to inspire some of our integral rules. So, as a brief review, something we talked about last week, something called the fundamental theorem of calculus. Okay? Is a very, very important structure, but the most important thing that we get from it is that derivatives and integrals are inverses, which means they undo each other. So, and this is so true that I'm actually going to write it out. Many rules for integration, that area finding, come from derivative rules. And we want to specifically talk about the some of our rules. So one of them is the product rule, but I also want to point out something called the chain rule. Okay, this right here is the product rule on top. This is the chain rule. And we know that this is the derivative of the outside of the original inside times the derivative of the inside. Okay? So, what should we be able to do? We should be able to take these two rules and write them in reverse. The left side loses d over dx, and the right side gains an integral. So what is that going to look like? Okay, specifically for the chain rule where we're going to start, f of g of x equals f prime of g of x times g prime of x. We can rewrite that as the integral of, we can say that f of g of x equals the integral of f prime of g of x times g prime of x dx. Allowing us to go from integration and derivation back and forth. Okay, so how does this help us? Well, before we actually do it, I want to make a note. This is sometimes called, in blue, this is sometimes called the substitution rule, or sometimes called, more generally, U-substitution. And something that we're going to do is we're going to call g of x equals u. Now, due to the concept of differentials, we're going to get these two things together. Okay? We're going to call g of x u, which also means g prime of x times dx, that is going to be a new du. It's a simple change. I shouldn't say simple. It is a change of variable name designed to make it a little bit easier to work with. So that's going to turn this actually into f of u is the integral of f prime of u du. And this specifically is simpler. Okay, so let's take a look at an example where we might need to use some u substitution. So here's the integral from 0 to 4 of x cubed times the square root of 256 minus x to the fourth times dx. Okay, so step 1, let u equal, and in this case, I'm going to choose u equals x to the fourth. And you'll see why I wanted to do that. So let's rewrite this. Now this is going to be the integral. We have x cubed. Okay, well, sorry. Before I write the integral, What does that make du? Well, derivative rule, bring down the 4, x cubed dx. Notice I have an x cubed and a dx, but I don't have a 4. But luckily, because 4 is a constant, I can put a 4 inside it as long as I put a 1/4 outside it. And you're free to do this specifically only with constant numbers. Okay? Don't try to do this with x's. So we'll do that rewrite. This now becomes 1/4 times the integral. We have 4x cubed dx. That's du. And I'm going to write that at the end just because it makes me feel better. This is going to be the square root of 256 minus u du. Okay? Now, notice this is still complicated. So maybe I didn't go far enough. In fact, let's call the whole thing, we didn't really make it that much simpler. So we go back to our drawing boards. Let's call u not just x to the 4th. Let's call it 256 minus x to the 4th. Now, please note, what is that going to cause du? Well, now it's going to be negative. We want a negative 4. And because negative 1 is a constant, we can still rewrite it. Okay? So if we do it now, we have dramatically reduced this. This is negative 1/4 times the integral of the square root of u du. Now, seems a lot simpler, but don't forget, we have some boundaries. And this was x equals 0 and x equals 4. But we're going from the x world to the u world. So, when x is 0, u is 256. And you can see that just by plugging in x equals 0 into here. So, if our boundaries are from 0 to 4 in the x world, in the u world, when x is 0, u is going to be 256. Similarly, when x equals 4, this will be 256 minus 4 to the power 4, which turns out to be 0. So in the x world, when x is 4, that's the u world when u is 0. So we're integrating the square root of u du. Everything is in terms of u, but we also have to make sure we pass through that transformation onto the boundaries. And now we can treat this just like a normal anti-derivative power rule. So this will be negative 1/4. Remember, the square root of u is u to the 1/2. We're going to raise the power of 1 and then divide by the new power. Is going to be from 256 to 0. Let's see what we get out from this. So first we're going to plug in u equals 0, and that's going to be negative 2/12. I'm just bringing this thing inside. Times 0 to the 3/2 minus, when u is 256, negative 2/12, 256 to the 3/2. Now, this turns out to be 0, and this turns out to be the negative times the negative. This will be 1/6 times 256 to the 3/2. I'll be honest, I'm going to go to a calculator. I got 49/6/6, which, once again, going to the calculator, is 2048/3. So, that's what u substitution looks like. And it's usually clever to choose this u, and this is a great choice. Anything that's going to simplify down is a good choice for u. And it's also a good choice for you to choose. Okay, let's choose another one. Another, substitution type rule. This will be the integral from 1 to 3, and this will be 2x over x squared plus 1 dx. Okay, so step 1, what am I going to choose? So again, I like to choose whole terms, and I like to choose high-level polynomials because, again, they're going to differentiate to be a little bit lower. So I'm going to say that u is x squared plus 1. That's going to make du equal to 2x dx. Do you kind of see how I already have that structure? Now, also, got to control the 1 and the 3. When x is 1, u is 1 squared plus 1 equals 2. And when x is 3, u is 3 squared plus 1 is 10. So in the x world, this is the integral from 1 to 3 of 2x divided by x squared plus 1 dx. But in the u world, this is the integral from 2 to 10 of du over u. And I do happen to know this integral, even if it's not obvious. Oh, I apologize. The question that I grabbed from your homework, it had a cubed there, which means that this u was being cubed. Which, again, if you think about it as u to the negative 3, what do? We increase the power by 1 and we divide by it. Then it just becomes a plug-in. So here's u equals 10. This is going to be 10 to the power negative 2 divided by negative 2. Minus, here's when u equals 2. This is going to be 2 to the power negative 2 divided by negative 2. Wow, lots of 2's going on. And at this point, I'll be honest, I'm usually grabbing a calculator. 2. Here I get, as a fraction, negative 1 over 200 minus, and here, 2 to the power negative 2 divided by negative 2, the fraction, I get negative 1/8. Negative 1 divided by 200 plus 1 divided by 8, I get 3 over 25. So once you get to this point, then it just becomes plug in to your calculator. But ultimately, you have to be able to choose the right u. And so the good choice, especially in this section, is to choose the highest order polynomial, something that will make it a little bit nicer. Now, this also comes in handy a lot, even on ones where it's not strictly necessary, if you really think about it. Here's something using a little trigonometric definition, which says the integral from 0 to the pi over 36 of the cosine of 6x dx. Again, I like to choose inside trap things. U is 6x. What is du? 6 dx. When x is pi over 36, u is pi over 6, just multiplying it by 6. And when x is 0, u is also 0. So we translate this. This is the integral from 0 to pi over 6 of the cosine of u. Once again, where do I get the 6 from? I can multiply by 6 as long as I divide by 6. And again, I can only do that with constants. There's going to be 1/6 times, what's the integral of cosine? Well, it's the same question. What has cosine as a derivative? Sine becomes cosine in derivatives. So the integral of cosine is sine. And we're just going to evaluate this sine at 0 and pi over 6. Okay, here's u equals pi over 6. This is going to be sine of pi over 6 divided by 6 minus, when u is 0, this will be sine of 0 divided by 6. Sine of pi over 6 is a half, so this will be a 12th minus, and sine of 0 is 0. Whoops. I kind of messed up that 1 there. But looks like we get our answer of the 12th. So, what is the substitution rule? How does it work? The substitution rule is just a inverse of the chain rule. And it helps us solve things that don't have obvious integral rules. For example, I'm not going to do this one. I don't know what the integral of x squared times e to the x cubed plus 8 is. But if I let x cubed plus 8 equal u, then it makes du 3x squared dx. I can get a 3 by multiplying and dividing by 3. When x is negative 2, u is negative 2 to the power 3. It's going to be negative 8 plus 8. U is 16. Negative 2 cubed. Oh, sorry, that's actually negative 8. It's actually 0. I did when x equals 2, u is 16. So go from negative 2 to 2 is the same thing as going from 0 to 16. We're going to rewrite this as the integral negative 1/3 times the integral of 0 to 16. All of this is du, and all of that is u. The integral of e to the u is still e to the u. It's the same derivative rule. Okay? So if you open up this section, which is 5.4 and 5.5, you're going to see a general integration formula. Just to kind of give you a couple of these, the integral of e to the u du equals e to the u plus c. And I want to say this c is called the constant of integration. And we'll talk about that in the next section. So good luck on this section. I hope it goes well for you. And I'll see you all. If you have any questions, again, please let me know.